certain substance starts to decay at 25 degrees Celsius. The half-life of the substance is 130 minutes. It takes 2.4 minutes to raise the temperature of the substance from 0 degrees to 15 degrees Celsius. A student obtained 100 milligrams of the substance with a temperature of 12.1 degrees Celsius. Place it in a room which has a temperature of 30 degrees Celsius. How many hours will it take to reduce 87% of the initial substance? So first, we'll solve for the time it takes for the temperature to reach 25 degrees Celsius with the given initial temperature of 12.1 degrees and the rate of from 0 to 50 degrees, we have a rate of 2.4 minutes and at the room temperature of 30 degrees Celsius. After we reach the time at 25 degrees Celsius, it will start to decay. And after it starts to decay, we'll solve with the given half-life. We'll be able to solve how long it takes for it to reach 87% of the substance.
So for the first part of the problem, we use Newton's law of cooling, or heat. This is the equation. Now we place the given. So at a certain time, there's a corresponding temperature. 0, 0. Initial time, 12.1. After 2.4 minutes, from 0 to 2.4 minutes, 15 degrees. Final time, 25 degrees Celsius. First, we solve K. Room temperature is 30. Then we integrate. So negative ln for T minus U is equal to Kp. So at T is equal to 0, 0 degrees Celsius. At 2.4 minutes, 15 degrees Celsius. So now we substitute the limits. Then we arrive at an answer of 0.2888. Now we solve for T final. At initial time, 12.1 degrees Celsius. At final time, 25 degrees Celsius. T initial can be treated as 0 because we solve for the time it takes from here to here. So T initial time is equal to 0. Now we integrate again, negative ln for T minus U is equal to 2. Then we again substitute the limits. Then we arrive at an answer of 4.40.
In the second part of the solution, we will apply the composition. So the given is the substance have a half-life of 1.5 hours, meaning that the substance will decrease by 1/2 of its original value in a time span of 1.5 hours. The amount of time to reduce 87% of the substance. So this is the formula for the composition. It doesn't matter if this is positive or negative, it's just for concept purposes. So transposing this, it will become this, and let's differentiate it. So integral of dx over x is ln x. The integral, since negative k is a constant, so we can get it out of the integration, as the integral of dt is t. So after that, let us put the limits, which is x and x. So from time 0 to time is equal to 1.5, the amount of the value will decrease by 1/2 of its original value. So next, let us substitute the limits in ln x. So ln x of 2 minus ln of x is equal to negative k 1.5. And applying the principle of logarithm, we would get this. Then, dividing ln of 1/2 by 1.5, we would get this. So after having the k, we can solve the amount of time to reduce 87% of the substance. So this is again the formula, and then this is the answer to this. Then now you might ask, why 0.13x? But the question says 87% of the substance. The value to be written here is not the substance that is reduced, but rather it is the substance left after a certain amount of time. So substituting that to ln x, we would have this, and then minus this. And then since we have k, we just substitute its value to k, and then dividing this by k, we would get 4.42 hours. So after that, we will add time t is equal to t1 plus t2. This is t1, this is t2. Since time t is 4.42 minutes and what is asked is hours, so after converting this 4.42 minutes to hours, we would get this answer, and t2 is 4.42 hours. So adding them, it would equal 4.5 hours. This is the final answer.